bends whenever it changes speed. So, anytime light goes from a material with one index of refraction to a new material with a different index of refraction, it will bend. As it turns out, similar mechanics plague illicit elven snail racing. You can see that Herbert Snail changed speed as she moved on the grass portion of the racetrack, causing her to veer off course. However, that's not the only lesson we can take away from this race course. It also happens that Herbert's pet snail is named Snell, and Snell should serve as a reminder of Snell's law, which is used to calculate the angle light will bend at when it travels from one material to another. Snell's law states that the index of refraction of substance, n1, times the sine of the angle at which light travels through that substance, theta1, is equal to n2 times sine theta2. And to remind you of n sine theta, Pesky Norbert tagged the race course with an n in front of those sines and the theta flowers in Snell's trail angles. With this equation, if you know the index of refraction for each material, you can measure theta1 and then solve for theta2, which tells you how much light-bending refraction should occur. As a quick aside, these track lanes run perpendicular to the grass-dirt boundary as a reminder to always measure theta from the normal, which is the imaginary line perpendicular to the boundary between substances. So when it comes to finding theta, don't be like Snell and stay in your lane.